Hello. In this video, I'm going to go through the week 4 activity from the Tuesday of week 4 in 2025. Now, this does need to get updated, although it'll probably help you out even if you're not watching this in 2025. However, to start this off, before we can even start working, we do need to get our working directory, get all that set up. So I'm going to set my working directory. This actually was 3 lines of code. It was an assignment creating WD. It was a dir.create, so a directory creating. I'm working on the wrong computer here. And then it was a set WD at the end. And I just strung them together with semicolons. I do actually do this sometimes at the start of my personal coding files. And that's just because it gives me a one-liner that does everything I need it to do to get things set up, which is sometimes nice and just makes it so I can kind of quickly check things and stuff like that. So, strategy. Next up, we got a download.file. It does what it sounds like. It takes this URL, which I guess if you really wanted to, you could type out manually from watching my screen. And it saves it to a file, dest file argument, on my working directory. I know it's going to be my working directory because there's no path up here. Had there been a path up here, then it would go into a specific location. But as is, it's going to go into my working directory. So I run that. I see some messages pop up. Once that's done, I can use read.csv. If you weren't sure how to do that, and generally you aren't, you could either just try it and just see if it works. And then if there was any problems, you might want to use this base import tool. So that was this button right here. And if you ever can't see the names of buttons, just remember you can expand the pane and see those names. All right. So whenever you did that, though, it would have helped you write this line of code. If you visualize it afterwards, we would see that we had some information. And we would you were asked to order it in a different way. And so what's going on here is I'm extracting columns of the data. So we can see right now pseudo-random has largely random values, although there's a few values that are there multiple times. And they can actually come from a different distribution. So like if I visualize this, I would see that it definitely was pseudo-random. The vast majority of, well, data is pseudo-random. It's hard to generate truly random values. But this data is, unambiguously not truly random. We'll go talk about pseudo-random eventually. This other column is the game column. This is where students just input their favorite games or what games interest them or whatever. And I am extracting them and then using them in this order function. And order is a funny little function. What it does is it analyzes the data in a way that would be useful for then putting it in order. It's indirect. It's a purely intermediate step. I'm sure I've done it, but I can't think of when I have actually looked at the output of order, like specifically for an analysis. I've only ever really used the output of order to do the ordering. I'm sure, like I said, I'm sure there are some fringe cases, but the vast majority of the time, the way we use it is in an extraction, because these values it's returned, those are the positions that if you are to extract them in that order, it puts the data in order based on the values you provided. So it's this intermediate tool, and it's just a really handy piece of code. So here I am. I pulled out the columns that I wish to order my data frame by, and then I'm putting them in order. When I do that, if I visualize this again, and this time I'm just going to visualize pseudo-random, well, there we go. We can see that it has been put in order. All those thousands are at the top. If I make the screen even bigger and I just try to visualize the whole thing, hey, it worked. Just barely it worked. And we can see that our pseudo-random's been sorted, and where there are ties, these are sorted alphabetically. So we have any Elder Scrolls, and then we just have Elder Scrolls, Baldur's Gate, and Zelda. That was me. I just like to overshare about my video game preferences. Fallout New Vegas, which I also legitimately could have put. Twilight Princess, World Ends With You, all very good games. I haven't played these last two, but very common choices as well. Okay, so we now have our data in order. If we check its class, it's a data frame. If we check the number of column names, Well, it's those values. It's not the number. It's the column names themselves. And if we look at the head, we've already done that. We could see if it matched my output. We are good to go. We're going to jump down to that demo section and just make sure that you've seen an example of how I might do some code. Now, when I first released this assignment to the class, I hadn't really gone through and added a bunch of edits for my process. I wasn't really sure how I was going to do it at first, but before I decided to just do this video, then anyways, so let's just go through it. The goal, and I'm just going to add some line breaks, and we're just going to kind of work our way through it. You can see my authentic thing, and then if you want to, you can go through step by step in my code down here and really read through my comments and all that. So first up, I'm just going to look at the data. So I have a column I wish to clean. It's filled with lots of legitimate values, but some are easier to interpret than others. And I may not know what some of them mean. I particularly like that one. Some of them I may not be able to interpret as a single color. So the entry I put was one that I like to put because it's a good question. I usually have a couple of students who give me something that isn't really a color. But this year, it was just me. I had to make up. I was the only one who didn't provide just like a value that was easy to interpret. I do have two people who just put nothing. So going through this, I have some cleaning to do. And, I can see capitalization is all over the place. Spelling is off in a couple of... actually, I don't think spelling is off this year. Oh, these years start to run together. So spelling actually is fine. Is that how you spell lilac? I'm embarrassed. I don't know how to spell lilac off the top of my head. Is that how you spell lilac? My R's not flagging it. So, yeah, there it is. Yeah, so one L for lilac. So one spelling error that I'm seeing, and then some little oddballs that definitely need cleaning. So really one of the first steps I often do, especially when I know I'm gonna be in like an iterative process, this is gonna take several steps, is I don't try to overwrite my original data, because I've too often realized that later on I need to change something, and I want to be able to easily start over. And if I keep overwriting my color column every time I mess up, I'm gonna have to go all the way back up to the top of the script file and re-import the data. And that's just a lot of work, and I don't want to do it. And for the real reason, it's easy to mess up. So I want to be able to easily start over. Like really, I want to get to the end of this, erase this column and check it and just make sure that my process is saved, that none of my kind of experimentations resulted in something being cleaned in the moment, but not the next time I shut everything down and rerun it. Like I want to make sure it's solid, like and consistent and repetitive and replicatable. That big R word for science. Okay, so I now have a new column called color clean, and if I check the contents, I think I'm gonna see that it's currently empty, and that's because I haven't run that line of code yet. But well, let's see what the problem is. I guess I have run it. If I run that, there they are. I must have a capital C there, just hard to see. A thing to be aware of. Avoid capitals. So lowercase c here. All right, now we've got a nice clean column. Let's start doing some easy cleanup. So some easy stuff. I can experiment. I can use like the table function. I can make my dog go stop barking at things. Give me one second. This is the culprit. Look at her guilty face. She was barking at other dog, Cinnamon. Cinnamon is enemy dog. All right, go have fun. All right, so let's get back into it. So we've got a table output. Table output's very useful for kind of just looking at overall trends. We can see there's a lot of greens. There's a few greens, some gray, misspelled lilac, blue, 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 lots of blues, lots of varieties of blues. We're gonna have to figure out a way to deal with that. We have two burnt oranges. We'll have to figure out that. We have a blank, which is always interesting. Blanks are these values. These are just literally empty character values. So R is interpreting them as a character, but it's There's nothing in there. So not NA, not null, not any of these other options, but empty character. Kind of its own thing. Yet another version of missing data. Something we have to take care of. All right, so let's do that. An easy way to do this is to extract those values. So if I extract those values, here I have coded in that column. I've compared it to the value quotation mark. That's going to give me logic. I can see those last two are the ones that are the problems. And then I've used that logic in an extraction. And why I would want to do this is it turns out that once you extract something, you can overwrite its values. And if I wanted to, I could overwrite its values with missing information. And I do want to do that. So let's try it. And I'm going to run table yet again. And when I run table this time, well, all of a sudden I no longer have that blank column. And that's great. And that's really why we're doing this, is to help us just start iteratively cleaning the data. All right. There's another one I know I can't deal with. So I'm just trying to currently get rid of values that I just have no way of solving. And that rainbow value is 1. Although, that was legitimately my input. Rainbow's not color, right? There is no way to represent the color rainbow because the color rainbow ain't a color. So here I'm going to extract it. You can notice that my extraction, because it's using logic, includes the NAs, although if I end up replacing NAs with NA, that's not a problem. Additionally, these aren't the NAs. These are just NAs resulting from logic that contains NA values. So just to clarify, this logic itself has NA values because I'm currently trying to compare not available to rainbow, and ours like, what would that be? That's missing information. What are you talking about? And it just returns missing instead of true or false. And then when that gets used in extraction, that still returns missing, not like the value or not the value. However, when I replace the values here, well, these are just basically nothing. Like they don't represent anything. They just represent that there was something strange that happened. But this rainbow is a legitimate value inside the data, and it's going to get replaced. And someone is just very clever, and that's how they decided to code those square bracket tools. And it works pretty well. You just have to kind of learn to embrace that kind of strange interaction. So here's the value that we just added. That was replacing that rainbow value. So at this point, I think we've really removed everything that is unable to be interpreted. Looking through here, running table, all of that, we can now kind of interpret everything. So just to add a few comments to clarify, creating new column of data needed for cleaning. Removing values with no meaning in context. And the next thing will be to clarify values with ambiguous meaning. So really, this is kind of removing errors. I don't think anyone in here had like a true error where like they typed something that means maybe these right here. But the ambiguous meaning is usually a decision we have to make. And this is where it can be a bit tricky because you may legitimately change people's like entries, or you may change the values when they mean something else. And it is one of those places where the data scientist may affect the outcome of an experiment. And obviously that would be something to be avoided. Like, we don't want the opinions and thoughts of the scientists involved to affect the results. And so we have to be very careful here. And I don't have a one size fits all. You can try to do some sort of smell test. Like, are you, well, I don't know. Look at that. Look at sage green. Like if I search for what is sage green, what is sage color? So sage color. Well, dang, this is actually quite variable. These are all pretty different colors. We can see here that it's a completely meaningless term, apparently. That's pretty funny. Yeah, those could not be more different, could they? Yeah, so clearly some sort of green, but obviously we see more green colors than any other color spectrum. So wow, what are we going to do here? There's a lot of options, but again, like that's probably the next most reasonable one for me to consider just removing because it is kind of ambiguous. Now, what we could do is we could look up like a color library or something, so that way, even if I can't get into the heads of the people who submitted these words, maybe I can at least make a consistent thing. So I could like go to some sort of color library. I think I found like color encyclopedia before. Hey, okay. Welcome back. So after a while of me searching through various websites with really bad designs, like, come on, people, let me just search on the website. It doesn't all have to be through Google. Anyways, I finally found a website, Encyclopedia. And this is not right. There's no there is no correct answer for what is sage, but it is at least a single database that I can now refer to. And that's really the key here for this discussion. Like the point is that I'm trying to make some sort of judgment in a consistent way. And at least going with a defined website or database is somewhat more consistent than whatever I feel like Sage should become. So at this point, I could start to go through and I could try and define some of these colors. So I could say like, I know I can at least define green, even if really they probably should have been more specific. I could say things like, well, with the color is sage. Well, let's see if they used a capital S or a lowercase s. They did use a capital S or a lowercase s. Then I could replace it with a hex code. And then I would come over to my handy database, I'd search for it, and I'd find, hey, there is a hex code here, BC, get that pound symbol in there, BCB88A. And then I would come back over here and I would paste it in. And hey, we can even see that R gives us this little handy coloring tool. So it allows us to visualize that color that's being added. Okay, so we have done a clean. There it is. It's working. We can see that's working right here. We could continue this process. We could search through several different things. We could make some more decisions like, what about all these other greens? And really, what about happens when you're just not sure what you're looking at? Well, and when that happens, I'm usually going to be doing some searches. So let me just clarify here that this was a safe clean. Had to match Sage exactly. This next thing, I wouldn't feel very safe assigning to dangerous clean because it's flexible. So here, if I'm going to search for, say, the color green, the search tool is grep. I'm searching the column color clean, and I'm using the results of that search, which are those positions, to extract from color clean again. That way I can see what those values are. Okay, so we can see some new things, and I have some options here. I could just replace all of these with the color green, and that might be reasonable. I would dare say that this is a neon green. I think that one is actually appropriate to replace with green, but I would also argue a forest green is not really green. Like, it's definitely not this. In my head, that's not what forest green looks like. We could go look up on our encyclopedia what forest green looks like. And we can see, oh no, people don't agree. These are all very, very different. And this is just kind of me getting at this concept of data cleaning. It actually is kind of hard. like there's legitimate scientific decisions you have to make, especially when you are like working with human stuff, because there is just so much, non-specificity in human language and in communications. So what I'm going to do is I'm just going to replace them all with green because I don't know the answer. And so rather than make something up that I really can't validate, I'm going to put a fairly safe answer. They are all, at the very least, a little bit green. And so it's dangerous, but maybe reasonable. And when I do this, I will see that that's changed now. So it's no longer pulling up any of those separate values. They've been replaced with just the value green, which of course still turns up in the search result. And so this is fine. We've done some cleaning. Now, there's a lot of other things I may want to do here. What if there was a capital G? There was. So if there was a capital G, I could leave off that G, or, and I think this is probably the better choice, is a little bit more pre-processing. So this is where it's going to be a good idea to kind of go back in time and maybe recreate things just so that I can make sure that I haven't pre-process lowercase. Just go back in time and make sure I haven't like messed up things through multiple versions of these objects. So to lower. And what that's going to do is it's just going to force them all to lowercase. Let me actually demonstrate this. This is a great thing to do at the very beginning. But there's going to be a problem when I do that. So we're going to start over and we're going to see what that problem is. To lower. That's still working. I could check it out. Hey, there's my NAs. And I could run this one. And if I scroll up to the top, hey, there's still a rainbow because when I got out of order, that capital R is now a lowercase r. And really, we're starting to get to the point where it's actually looking like kind of this actual code. And we're starting to demonstrate this process of this iterative iterative cleaning, where I'm going through and I'm kind of checking and visualizing things. Okay, let's just add more line breaks because that keeps getting me confused. So this is where we've ended up. I did do some edits, so I'm just going to rerun all that one more time. And we're going to visualize the results so far. We're starting to look pretty good. First of all, this table is getting smaller and smaller as a lot of those capitals and lowercases have now been combined. Some of our values, such as green, dark green, lime green, or neon green, and forest green, they've all been combined into just green. And now we can kind of continue this process. So at this point, I think I'm going to cut off this video because I think you're getting the idea, and I've already demonstrated all the concepts. We have these ideas where we can use search for either replacement, like I've demonstrated here, or maybe just purely exploration. I did think of one while I was talking, so I'm going to do one more example. I could do something like blue. And here I can see that there's a couple different blues. I also saw while we were in there, navy. And so I might start thinking to myself, all right, I need to do a little bit more cleaning. There was also like a sea foam, I think. So if I add C in there, there it is. So I may want to replace all those with blue, but just for safety's sake, instead of using this kind of dangerous tool, I might use a tool like % and %. And let's show you what that would look like. So for % and %, we're still going to be cleaning, so we're still going to need to do some sort of like logic, and we're going to need to do an extraction and replace the values in that extraction, but the % and % will allow us to do like an exact test. And so we're going to use cornflower blue and sea foam. It's going to need a comma in there. We're going to use navy. And what we have now is logic that says error. Right there. We have logic that now says for each value in color clean, is it in this vector? And anywhere that it was in that vector, which is anywhere it now says true, we're going to extract, and then we're going to replace them with the word blue. And so the next time we do the search, it no longer pops anything up. If we visualize the results afterwards, those extra things are gone. Now all we have left is burnt orange. And this is a fun one because well, let's do a good test. So I could do another dangerous exploration or a dangerous replacement where I just like search for the word burnt. But, you know, if we think forward, anytime there would be like a burnt umber or a burnt sienna, those aren't burnt orange. And so those wouldn't be very good matches. And so a grep using burnt is kind of dangerous. But the other thing we'll need is what is burnt orange. Now, we exist at UT Austin here. And so burnt orange UT hex code. They probably mean the official burnt orange color, even though there's probably many colors that are called burnt orange. I bet at UT someone has sat down and defined what is the hex color for UT's burnt orange. And that's true. They have right there. We also could have picked charcoal, and apparently we've picked white, although we have the most basic white. It's just a true perfect white, completely saturated color channel. Yeah, so we have that now. So that's the color we're going to replace. We can check to make sure R interprets it. Yes, it does. And now we just need to get the strings formatted correctly. And let's see if we did that. Yep. So when I ran that extraction, I'm extracting color clean, checking to see, is it in this object joined by C, using that resulting logic in an extraction. And there is the results of that extraction. And then I'm going to replace them with this new value and then check my results. Okay. Those burnt oranges are gone, replaced with validated school of cockerel school color defined burnt orange. And at this point, we have fairly clean data. I think we have lilac that still needs to be adjusted. So we could just replace lilac with, I'm just going to copy and paste because I'm starting to get a little tired. And there we go. Those are all looking pretty good. If we weren't sure of what it would require, I did write a piece of code that's a little bit, I don't need to explain it. It's just kind of looking at the unique values. It is then putting text around them to literally help me write the code. And this is nice because if I then come down here, I can just paste it in and hey, there's my values, which is kind of cool. I could also use those values in some sort of analysis. I'll have to move my head here. Nope. Oh, well, that works. And yeah, there's our sage down there. There's some burnt orange. There's a gray, I think. Or no, there's gray. Lilac. That's lilac. And we can see that, you know, by far blue is the winner. Maybe green, although for both blue and green, we had to make some decisions that are debatable. And maybe, you know, one of those should not be winning. It's probably almost tied. And this is where sometimes, yeah, like I said, the data scientist has to make decisions that may legitimately affect the outcome of an analysis. And it's just a thing to be aware of. Okay, next up, we've got the section on questions. And so down here, I'm asking you to go through each of these questions, analyze the code, respond with code, stuff like that. So let's just dig right into it. At this point, I am having you look at the game column. There we are, game column, lots of different games. I'm converting them to lower. Cool, so all of those lowercase names now. I'm then calling the table function. We can see where they start to stack up. That some, like, we have 1 Resident Evil, we have 3 Robloxes, 16 or 15 Minecrafts. Everybody spelled Minecraft correctly, interestingly enough. A lot of different Mario Karts, although nobody agrees on how to spell it, which is always true. I use this as my example every semester so far. And actually, this is the first semester Mario Kart hasn't won the popularity. We also have 6 people who have said nothing. And we have 0 people who said NA. Now, the only reason I'm seeing that NA is because of this argument. And if you weren't sure what that argument was, you could open up the help file for table. So I typed that in wrong. !" table is how you would do that. When you ran it, you'd get this help file up. Although I'll be honest, I think that help file is not the most helpful. We have one argument called use NA right here. Those are its 3 values. And by default, most functions operate by taking the first value when they're described in this way. So they'll describe what the different values possibly are, and then the default value is that first one. Here it says whether to include NA values in the table. So that's actually fairly interpretable. The main problem is just because, well, there's also a use.NA here. But this is in regards to this exclude argument, which is a little bit harder to understand. It also uses an old syntax that I don't generally recommend for students. Additionally, there's some longer details down here, but honestly, I think these are harder to understand than simply what it says right here, whether to include NA values in the table. Okay, so that's what's going on in the table function, and it's adding up how many of each value. And finally, we're then sorting it. And when we sort it, we can see that these values are now in an ascending order. So all the ones down here, that NA with 0 should be at the very beginning. There it is. And if we come down to the bottom, we can see that, yes, indeed, Minecraft is currently winning, followed by Mario Kart and followed by nothing. Let's talk about that in a minute. So that's really the answer, is that if you run through at least what I typed in, this code first extracts the values in the game column. That's true. That was the $sign. Then it converts the strings to lowercase. That's true. That was the 2 lower. Counts how many of each unique value occurred and reports how many were in A, and that's via the use na argument. And then it sorts the output based on how many were counted from least to most, ending in Minecraft. Okay. So this next one is what's going on with that value that has no text above it. So that's what I've highlighted right here. That's where we had people who just put nothing. So like not the word nothing, but literally just no text. And it's a little bit easier to see when you visualize the vector directly. We can see that there are some people who just put nothing. Next up, we've got detect the positions of empty character value is how I will be referring to that in class. And then I say use it using the double equal sign, so the R equality. And in that situation, I'm literally just checking, is each value in game equal to the end character or empty character value. And when we do that, I say detect the positions. Those are the, that's logic. However, I ask for positions, so we can use the which function to kind of convert that logic into the positions that are true. So such as 111 and 112, as well as 98 and 88 and 87 right there, and then up somewhere up here 35. But then the next one was using partial string matching, so a regular expression, try to detect it. And this is the one that's, kind of the actual tricky one. So grep is a partial string tool. It returns positions. And I think this is easiest to demonstrate by what happens if I don't put any special characters. And so when I don't put a special character, I get literally everything. And the reason why is hard to see right now, but if I do a G-sub instead, here I had, oh geez, I had Minecraft. In between each position, there was an empty character. And so it's literally gone between every single letter of Minecraft and added a Z, because that's where it found an empty space for a character. It even did it at the beginning and end, which gives you a little bit of an insight into how G-sub ends up working whenever you're using that beginning and the end. However, if I wanted to signify take the beginning and take the end, and they need to be straight right next to each other, I can use those symbols that stand for that. And now that says, all right, anywhere that the beginning and the end are touching, add a Z. Well, now I can start to see that that's only affecting the values where those were empty. Now, I didn't ask for a G-sub. G-sub's just a little bit nicer when you're trying to visualize what the replacement will be. I asked for which positions have a match, and that's going to be successful. So, in summary, end or beginning of the string symbol, end of the string symbol, if they're touching, then that's an empty character vector. Next up, we have explore the game column using unique and table and grepl functions. Write a single regex pattern that finds any value representing I don't know or none or nothing. And so well, let's search for that. So let's just do table. Unique or table really would have been the best options. Well, let's do unique. Unique's a good option here. We haven't done unique yet. The nice thing about unique compared to table is that oh, sorry, I'm talking while thinking. So here I'm extracting the data. I'm converting it to lowercase. That way I don't have to look at duplicates with different capitalization. And then I'm going to look at unique. One of the big differences between unique and table is that with unique, you're going to see the actual character vector, which is nice because it lets you see some stuff that sometimes it's hard to see inside the table's output since it has to format it around the counts of things. So looking through here, I can see, well, it's a little bit out of order. So let's add something to our code. Let's add the sort function. So that way I can kind of parse it a little bit more carefully. Oh, that's much better. All right, so we can see, first of all, there's some values we'll need to remove. That makes sense. We've already discovered those. I think there was an IDK, yeah. So I don't know is what that stands for, presumably. Here's a nothing. I usually have some nones, no nones this year. And yeah, there we go. So we have three values we're really trying to get out with this: IDK, nothing, and empty. So I could write 3 different tests and replace each of them with NA. However, here I'm just asking for write a regex pattern that tries to find any value. And so a regex pattern going to have to be, a pattern is going to have to be in quotation marks. Well, we've already written one, so that was beginning and ending touching. And then there's a symbol that stands for or. Note, I'm not putting any spacing around here. If I put any spacing around here, that would be part of the pattern. And that's not one, I don't want that because these are often empty. So I need it to be very precise here. Now, one of my choices was nothing, and that was the whole value. And I could even get a little bit closer into there because, like, what happens if, you know, there was a title that contained the word nothing, but it wasn't the concept nothing? Same thing for IDK. I could be very specific there if I wanted to. At this point, though, why am I not using like a better test? And it's just because I'm trying to demonstrate regex. This is a legitimate option. I would usually, in this situation, whenever I'm checking for specific values, I do usually want to use things like percent and percent. That way I can do these exact matches and make sure that there is no, like, you know, there's no IDK as part of a longer name that could become picked. Although this strategy of signifying the beginning and ending of the string also works, and it technically fits in a lot less keystrokes. So it's not a bad choice. It's just a little bit more dangerous. And there we go. I could simplify that further. I think my answer did simplify it further, but this does work. Next up, we've got make a new version of StuDF called StuDF2. StuDF2. StuDF. All right, done. Make this new version contain only rows that have the actual games in their answer. And so in this situation, what I could do is I could take my previous search and I could use it in an extraction. But there's a problem with what I've currently typed. What I've currently typed is just the rows that I wanted. And so I could rewrite my logic, and that would be kind of hard. Or I could create grepl instead of grep and then reverse it. That's right. So now it's the opposite. Now it is, what are those rows that don't have this match in them? And that's just this clever way of trying to overcome some of these smaller issues. All right. Did I get rid of nothing? I don't think I would have. I didn't, because I put nothing. I actually added that one in. So in this situation, I could change this to lower. And in that situation, this grepl will no longer pick that out. If I make sure that I'm analyzing StuDF2, so that way it all matches up, I won't see those missing values that popped up a minute ago. So like right here, that was a problem. So now that they're all in agreement with each other, I am converting these to lower. I am then searching through with my regex. I am then using that regex in an extraction, but first I'm flipping it. Now, right now, it's all false because when I ran this previously, that did erase those values. But if I restart this process, I can see that those false values are now being excluded. So those are our nothings and our IDKs and our empty character vectors. Finally, I'm using that logic in an extraction. And then I'm just double checking. It's looking good. So now I'm having you finally actually put the lowercase values in here. Probably should have done this earlier. That's usually one of my first steps when doing these sorts of things. But honestly, it's good practice just to point out to y'all. Turns out stuff like this happens all the time. I even messed up in that. It may have seemed like I was doing that on purpose. I probably didn't, but I didn't. That was a legitimate accident. But it's just that's a really common issue, and so that's why one of my most frequent things to do is remove lowercase values. So in this situation, and it's actually fairly easy, I'm starting off by doing it to just the column names. So in order to overwrite column names, we can simply take the column names and assign them new values. Since I'm wanting to assign them just the lowercase values, then I could just take those column names, convert them to lower, and overwrite the original column names. Now when I do that, they're all lowercase. Now, in actuality, I would usually follow this up with doing that same thing, but for the game's column. Yeah, I don't think I did in this question, though. Correct. All right, next up, we got write code that uses regex to return the unique values of everyone who seemed to not respond with some form of Mario Kart. So I said not respond with some form of Mario Kart. Sort them alphabetically. Nolan's answer, but without the grep family function, we're just going to do the full answer. So I scrolled through and I was like, all right, well, what are all the forms of cart that are in here? And it really comes down to two. It comes down to cart with a K and cart with a C. Well, it turns out Mario Kart is spelled with a K, like that's the official spelling. But people don't know that because the English word for cart is spelled with a C. So you could just have searched for that after having run to lower. But since we haven't run to lower in this current series of data cleaning, we either have to convert what I've highlighted to lower directly or simply expand our search options. And so I'm just going with search options. I'm first searching for cart and cart and cart and cart. I'm then getting logic from that. That's going to be trues and falses. And then I'm flipping that logic using negation symbol. That negation symbol is going to result in all of the positions that are not some form of Mario Kart. And then I'm checking out the sort and unique values to allow myself to double check, hey, did I actually find them with that search result? And looking through here, yeah, there's no other Mario Karts. There's no somewhere where someone forgot the M, so it's like Aereo Kart or something. And then finally, I say write code that replaces all mentions of Mario Kart with the value Mario Kart was spelled correctly and capitalization consistent. And so I would just take my previous code, so that grepl response. Instead of having an exclamation point, though, I'd leave that out, causing me to just extract the actual values that I have found in my search, and then replacing them all with the value Mario Kart. And now when I rerun that, I can see that Mario Kart has indeed been replaced. And that's where I say it has finally been dethroned. So we should check to see where it fits in, and call table. So we've already done that. So let's just call table on it. And right now this is table, but unfortunately we'd have to scroll through. So really the best way to fix this would just be to sort the table. Additionally, we still do have some multiple spellings. And so for the 15th time, it feels like, let's run to lower. This is why I always do to lower at the very beginning. And now we can finally see that indeed Minecraft has finally beat out Mario Kart. For the first time since I've come to UT, Mario Kart has been beat out by Minecraft. So congratulations, Mojang. I don't actually know how to pronounce it. I've never said it out loud. Yeah, that was fun. I don't think I added, yeah, that was exactly what I put. Okay, write code that uses regex to return all values starting with M and ending with a T. Really just going for it, huh, Nolan? So we're going to do some regex. We're going to be searching that same column. I didn't actually say that. I meant the game column. So I guess I'll have to fix that wording. And I wanted all things starting with an M and ending with a T. So something's got to go in between here. Well, it could be any character 0 or more times. So if I had MT directly next to each other, that would be appropriate. Minecraft and Mario Kart are going to have different links, so I need this to be flexible. And additionally, I want to ignore case in some fashion. So I could write every permutation, so I could be capital M through lowercase t, lowercase m through capital T through, or capital M through capital T, or I could take the much easier solution of just making it all lowercase. And again, the reason I would always start off with this is that you have to do it so many times otherwise. All right, and with that, we can see it. Now, of course, those numbers aren't super helpful by themselves, so let's check out those values. I'm using that in an extraction. And so I want it to be starting with an M and ending in a T. And so instead of things that just contain an M and eventually have a T, it should start and end with a T. And with that, you need to use your start and end symbols. All right. Well, that's it. So we went through that. That was a long video. 51 minutes. That's not my longest this year, but that was longer than I was expecting. I hope that helps. If you do have any specific questions, please let me know. And have a good day. I gotta stop doing that little tongue sound at the end. That's not good. Bye.